Hello, everybody. So I know I didn't get to see any of you in class yesterday, but when I got to talk to you for a few minutes before we left for the day, a lot of you said that you were really struggling with these homework problems from 1.8. So what I'm going to do for today's video is I'm just going to work through several of the odd numbered problems since I assigned you the evens. That way, hopefully it will clear up some of the confusion and can help you guys figure out what you need to do. So let's start with number 3. So that is the cube root of 128. So we're going to split 128 up into its different factors. All right, so I'm going to do 8 and 16. I just like to break it up into smaller factors. That way it's easier to break up from here. But you can use anything that divides into 128. So you could even do like 2 and something, or yeah. So you could even divide it by 2 and split it up from there. It doesn't matter how you start. You just have to break it down completely. So then 8 we can split into 4 and 2. And then we can do some 2's there. 16 we can do 4 and 4, which gives us 2 and 2 and 2 and 2. So since this is a cube root, we have to circle things in groups of 3s. So I've got 3 there and 3 there, which means that this 2 is going to be left inside of my cube root. So there's my cube root, right? I'm going to put my 1, 2 outside. And since I circled 2 groups of 2's, that means I'll have 2 times 2 on the outside, right? So I've got 1, 2 from one group, second 2 from the other group, and then I multiply those 2's together to give me a final answer of 4 times the cube root of 2. All right, now I'm going to skip ahead to number 9, which is the fourth root of 243 a to the 7th, y to the 5th, z to the 3rd. So we're going to take our 243 and divide it down into its factors. So I divided it by 9, so that's going to give me 9 and 27. So 9 goes down to 3 and 3. 27 is 3 and 9. And then that 9 also splits into 3 and 3. So since it's a fourth root, we're going to circle in groups of 4. So we have 4 3's. Right, and remember, we're only worried about the stuff at the very bottom, like stuff that's broken down as far as it can go. So we have 4 3's, and we have 1 left over. So that means in our fourth root, right, I've got 1 3 inside and 1 3 outside. Right, I left some space because now we've got to deal with our variables. So remember the shortcut I showed you where you take the exponent. So let's look at our a to the 7th. So we're going to take 7 and divide it by 4. So 4 goes into 7 one time, right? And then that leaves you with a remainder of 3. So that means this top number goes outside, right? And the bottom one is our exponent inside. So that means we have an a to the 3rd left inside, but then we have 1a outside. All right, we'll do the same thing with our y's. So y to the 5th, so it's a 5th power, but we have a 4 out here, right? So 4 goes into 5 one time, right? So that means we're going to have 1a inside and 1a outside. Or I'm sorry, y. So a y here and a y here. And then looking at the z's, right, we only have 3 here, so we can't divide it by 4. So that means all 3 of these are going to stay inside the radical. Right, so that makes our final answer 3ay times the fourth root of 3a to the 3rd y z to the 3rd. So in order to take something out, the exponent would have to be bigger than the index. Remember, this is the index, whatever that little number is with our radical. All right, next let's look at 13. So that is the cube root of 16 plus the cube root of 2,000. So we need to break these up so that we can make them smaller. So 16 splits up into 4 and 4, which each gives us 2 and 2. Great. Cube root, we circle in groups of 3, so that means we're going to have 1, 2 outside, 1, 2 inside. So that means it's going to be 2 times the cube root of 2. And then when we split up 2,000, let's go with 20 and 100. 20 is 4 and 5. 100 is 4 and 25. And 25 gives me 5 and 5. So I have this group here. So we can take out, oh, I didn't split my 4s. All right, I'm going to redo that just because it's hard to follow. All right, so 20 is 4 and 5. And then that 4 goes to 2 and 2. And then we have 4 and 25, which is 2 and 2, and 5 and 5. So I have 3 2s and 3 5s. So that means on the outside I get 2 times 5. And on the inside, all I have left is this 2. So that means I have a cube root of 2. So then, 2 times 5 gives me 10. So we have 10 times the cube root of 2. And then this one is just 2 times the cube root of 2. So all I did was just bring those down to make this neater. And then once you get to that point, you just add your 2 and your 10, which is 12, and then you keep that cube root of 2 on the end. All right, let's jump ahead to 19. So for that one, we have 6a times the square root of 3 times 5 times the square root of 5. So for this one, we're going to multiply our outside stuff, which is 6 and 5, which gives us 30. And then we multiply inside the square roots, which is 15. So it becomes 30 times the square root of 15. Oh, and there's an a with that 6. So 30a times the square root of 15. So when you're multiplying, you just multiply the outsides and then multiply the insides, and then you simplify it if you can. But if you can't, that's okay too. Oh, and go ahead and skip number 22. We didn't go over how to do ones with a different index like that. So you can skip problem 22. All right, I'm going to do 27 next. That's one where we have to FOIL. So it's 3 minus the square root of 5 times 1 plus the square root of 5. I think I might have done this example in class, but that's okay. We'll do it again anyway. So when you have problems like this, you have to FOIL. So the first two multiplied together, so 3 times 1 is 3. Right? Then we do outside, so 3 times the square root of 5 is 3 square root of 5. Then so that we've got first outside, inside is minus 1 square root of 5. And then last is minus the square root of 25. So we have 3, and then we can combine these two. So 3 square roots of 5 minus 1 square root of 5 is 2 square roots of 5. And then the square root of 25 is equal to 5, so we change that to a minus 5. Now we do 3 minus 5 to give us negative 2 plus 2 square root of 5 to get our final answer here. So when you're doing these FOIL ones, whatever you get on the end for your last, you should always be able to take the square root of that. All right, and then finally, let's talk about our division. So let's look at Let's look at 33. I don't know that we ever did an example like this. So we have a fraction under a radical. So what we have to do is split that up into a radical over another radical, because we can't simplify the square root of 2 or the square root of 7. However, in math, we don't leave radicals in the denominator of a fraction. So what we have to do now is what's called rationalize the denominator. So what that means is whatever's on the denominator, which in this case is the square root of 7, we're going to multiply by the square root of 7 over the square root of 7. And so we just multiply straight across. So then on top, that's going to give us a square root of 14. And on the bottom, that would just give us the square root of 49 or 7. So then this would become your final answer for ones like 33. So like for you in 34, you're going to follow that same process. And even in 35, oh, you don't have to do 35. Like for 36 even, you're going to do that same thing. You want to simplify your square roots if you can before you multiply. So like in 36, reduce down that square root of 27 you would get on the bottom. All right, and then let's look at one like 37. So this was 33. Let's look at one like 37. So for that one, we have the 5th root of 11a to the 4th over the 5th root of a to the 3rd. So we can't reduce these at all. But what we can do is we can kind of do the opposite of what we did in 33. So we're going to put this all under one radical. Right? So you can do that with division. So we have 11a to the 4th over a to the 3rd. But now we can divide that. We can divide that a to the 4th by a to the 3rd. So that's just going to leave us with the 5th root of 11a. So for these division type problems, you're really just trying to simplify where you can and make sure that you're not leaving any radical symbols in the denominator of your fraction. Okay, I hope this clears up some of the issues you guys had today. Just please continue working on that page 54 and 55, that 2 through 40 even. Right, that I assigned on Friday. 10th grade, I know you guys didn't get through the division, but what I covered today should get you through the rest of those problems. So please submit that in, go ahead and submit it in the Tuesday assignment if you don't mind. That way I can find it and we can check it. I think we're going to hold off on our quiz until we come back. But I am going to tomorrow post some extra practice questions so that you guys can keep working through these skills so you can feel a little bit more confident in it. All right, I'm sorry this is a long video, but I wanted to make sure that you guys got the information you needed to successfully complete that assignment from Friday. I know we got kind of rushed Friday trying to get through everything. So please let me know if you have any more questions. If we need to, I'm available this week. If you guys need to hop on Zoom and like go over stuff with me, I'm more than happy to do that. Just please reach out to me and let me know. All right, I love you all. I'm praying for you and have a good day.